Welcome everybody to the first seminar of our series on evolution and social systems. My name is Sergey Gavrilets. I'm one of the organizers of this webinar, and I'm having problem, unfortunately, with my video. Our co-organizers are Tom Curry from University of Exeter and Pete Richardson from UC Davis. We also have Eric Carr helping us the same way as the last year here. This seminar webinar is sponsored by the Center for Dynamics of Social Complexity here in Knoxville and by the Group for Social and Cultural Evolution at the University of Exeter. And funding is provided by John Templeton Foundation and by the European Research Council. This is a continuation of the webinar series that we ran last year. And if you missed our the lectures that we had here, I encourage you to check our DySoC website. Just a few words about the format. The talks will be for about 45-50 minutes, when we'll have a moderated Q&A session for 15-20 minutes. That means that you'll have to type your questions in. We'll also have several panelists here, and these are speakers in our series who will be able to ask their questions directly. Next, I'm going to ask Tom, Pete, and Eric if they have anything to add to what I just said. Tom?
Nothing much to say, but looking forward to a great series of talks this term.
Pete?
No, I have nothing, Sergey. I am also looking forward to talks.
Eric, I'm sure you missed something about some important things.
Yes, the only thing to take into consideration is that we will be using the Q&A feature of Zoom Webinar. If you look on your bottom bar, there's a little Q&A icon. You can submit questions there that will be moderated by Tom at the end of the talk and be asked to Simon Levin. We're looking forward to a great talk. Thank you.
Okay, we're extremely happy to have a very distinguished speaker today, Professor Simon Levin from Princeton. But first, I want to introduce the person who will be introducing Simon. And this is Professor Lou Gross, who is professor in ecology and evolutionary biology and also in mathematics. Lou is actually one of the first students of Simon. He's also the person who's been building an extremely successful program in mathematical ecology and evolution here in Knoxville for the past almost like 40 years. He has done a lot as a scientist. He has also been extremely helpful and influential within the Society for Mathematical Biology. And Lou has been doing extraordinary work as here on campus. Right now, he is the president of the Faculty Senate, and this is the second time around. Lou also was the main driver behind the success of the National Institute for Mathematical and Biological Synthesis that we had here for 12 years. And DySoC, the Center for the Dynamics of Social Complexity, is one of the spin-offs of NIMBioS. I think it's fair to say that without Lou's energy, persistence, and effort, we would not be able to do much here on campus, and I think the whole science would not be there. Lou?
Sergey, thank you very much. That was a very kind introduction, and I must point out that our programs here at the University of Tennessee, Knoxville, arose from a long-term collaboration with Tom Hallam, who Simon and I spent many years collaborating with in building a series of courses and workshops at the International Center for Theoretical Physics in Trieste in Italy. It is really my pleasure to welcome Simon as the lead off on this series this year. Simon is the James S. McDonald Distinguished University Professor in Ecology and Evolutionary Biology at Princeton University. His career has involved hosts of questions associated with how the world came to be as it is. And he's addressed this in many, many novel ways, including accounting for the spatial heterogeneity of systems and how that impacts the structure and function of natural systems, the connections between economics and social systems and natural systems, the impact of observing different patterns and scales on the hierarchy in systems, and many, many issues associated with the emergence of collective behavior. So Simon has received many awards, rightfully so, associated with his research, but I will say that as a mentor to generations of researchers at every career stage, he has been an exemplar of what we would call in Yiddish a mensch. So Simon, it is really my pleasure to have you join us for this. And the talk title today is Public Goods from Biofilms to Societies. Simon, thank you very much.
So first of all, thank you for inviting me. It's a pleasure to be here. It's always a pleasure to be back with my friends in Tennessee. And thanks, Lou, for that wonderful introduction. Let me say that of all the things in my career, the thing I'm proudest of or gives me the most pleasure are the terrific students who have I've had the pleasure of interacting with over the years. And people like Lou just has made it all worth doing. So thank you. Today's lecture is called Public Goods from Biofilms to Societies. And I want to, first of all, thank the various funding sources that have helped me over the years to support the work I'm going to talk about. Whether we're talking about microbial systems or all the way up to socioeconomic systems, and I'm sure we've got people here today who are interested in the systems at all these levels. One of the features is that macroscopic patterns emerge from things that are going on at microscopic levels, which introduces some fascinating evolutionary problems because the evolutionary pressures are generally at lower levels of organization. So all the way from cellular slime molds, in which the pioneering work was my colleague here at Princeton, John Bonner, but also the famous mathematical work that Evelyn Keller and Lee Siegel carried out has made this a prototypical system. But it goes all the way up, and this is just for Lou, this wildebeest slide, that large animal aggregations also emerge from local interactions in which individuals are carrying out their own selfish agendas. This is a large wildebeest herd, and there may be some zebras out at the front. It's a little hard to tell, but these fantastic patterns emerge from individual interactions. These are public goods. This remarkable picture of the starlings, which I showed you in the first slide, forming what certainly looks like a giant starling or perhaps a giant raptor, illustrates that there are benefits in being part of these groups, and yet the question is whether individuals will pay the price that's associated with belonging to this group and gaining the structures that perhaps can offer protection against predation. But this inescapably leads to conflicts between levels. This is the source of our problems in dealing with the global commons. But perhaps the simplest example is of tumor cells, which grow rapidly in the short run, gaining a benefit, but there's a long-term cost to the organisms of which they are parts. So the question is whether we are in fact tumor cells in the global environment. This creates challenges for societies, trade-offs between the interest of the individual and the interest of societies, and therefore the need to scale from individuals to the ensembles like those bird flocks of which they're part and back down. So if you look at this picture, you'll see thousands of starlings, and if you look carefully, you'll also see one hawk up there that's driving this behavior. You'll see this more clearly here. I don't want too much feedback, but we get these spectacular patterns, and since my graduate training was in fluid dynamics, it was just too tempting not to work on systems of this sort. So the question I want to address is, can we achieve this sort of cooperation at the global level on dealing with climate change and other environmental problems that are going to be needed? How can we achieve cooperation in the collective good? And I want to turn first, because of the nature of this lecture series, to ask, how does nature do it? How is it that many individuals can team up to offer protection against, for example, a predator who's larger and more menacing when one individual is involved? There are a variety of problems that are of this nature, in which one has to really be thinking about how natural selection is going on at multiple levels of organization. And this is a piece that we have basically in press, led by my former student, Dan Cooney, in the Siam News. So this should be out soon. To give you an example, in the starling flocks, people who have studied those flocks over Rome observe that the birds seem to pay attention not to the individuals in some geometric neighborhood, but to approximately the 7 nearest neighbors, something that people working on this problem call a topological neighborhood. So a natural question is, why 7? And my colleague, Naomi Leonard, who is a control engineer, approached this from the viewpoint of the whole group and showed that 7 under these conditions is about what would maximize robustness, which is a public good. It's beneficial to the whole ensemble. But the natural question arises, and this is something that Bill Hamilton made clear in his paper called The Geometry for the Selfish Herd. What's best for the group is not necessarily what's best for the individual. So Naomi and I had a wonderful graduate student named Eleanor Brush, and we proposed to her the question, well, suppose we thought about this not from the viewpoint of the group, but from the viewpoint of the individual, and asked, from a game theoretic point of view, what should individuals be doing? And so she investigated a number of models under different conditions with different feedbacks, and found that what was good for the individual was not necessarily what was good for the group. And in fact, it depended upon the task that was being performed. For those bird flocks that you saw, the task is probably protection from predation. But what Eleanor, or what we found, but Eleanor really was the lead in this, is that the evolutionarily stable strategy number of neighbors is less when the goal is finding resources than when finding predation. So my interest in this goes back long before this. It goes back to another graduate student, Danny Grunbaum, who was working on krill aggregations, but trying to understand the resolution of what's good for the individual and what's good for the group, and thinking about things at multiple scales. These are game theoretic problems, but not your normal game theoretic problems with 2 players, something like the prisoner's dilemma, but with many players. And it's led to interest in a whole new mathematical approach to these problems, with which we have just begun to investigate, called mean field games. This is one of the classic books on the subject. And basically what happens in these, and by the way, I discovered when looking this morning, this rather entertaining website. If anybody's interested in learning about mean field games, this particular website I think might be a good place to get started. But basically what you end up doing is, instead of looking at things in a standard game theoretic format, you end up writing a Fokker-Planck equation for the mass of all the players in the system. Going from individuals to collective and writing equations for the ensembles is something that I and my colleagues have been interested in for a long time, including Danny Grunbaum, but especially Glenn Flarrell. And if you're interested in that, this is a paper we wrote a little more than 20 years ago on how to go from Lagrangian models, individual-based models, to the aggregations, how to go from the equations governing the dynamic, what individuals will do, to the ensemble. And we'd love to be able to do this in dealing with decision-making in human groups. And I'll point out that even whether to be part of the group is a game theoretic problem. One of Lou's great contributions to me was sending me Errol Akçay, fantastic postdoctoral fellow who spent time now down at NIMBioS before coming here, who asked the question, where we work together with two political scientists, when there's a collective task to be performed, are individuals better off going it alone or joining the group? And for those who are familiar with the economic tools, this is what's called a mechanism design problem. So this paper appeared in PNAS 9 years ago, and if you can't find it, happy to send it to you. But more generally, these are public goods problems, and public goods problems and common pool resource problems are widespread in socioeconomic and ecological contexts, not just the tumor cells that I already talked to you about, but the sorts of situations that motivated Garrett Hardin and William Forster Lloyd before him, where there would be a trade-off, for example, between multiple fishermen or multiple fishermen competing with oil rigs offshore in a common situation. And how do we resolve this? The fact that you see similar sorts of questions in ecology and evolutionary biology suggests that the sorts of insights that Adam Smith developed in ecology and that Charles Darwin developed in evolution can inform one another, and indeed they do. Indeed, ecology and economics are two sides of the same coin. Ken Arrow, the late great economist, pointed out to me that it's no accident that the words ecology and economics both start with the same 3 letters, which actually is the word for household. They're two sides of the same coins. So public goods and common pool resource problems, and I'm not going to go into details on the difference between them, but they all deal with situations in which individual actions potentially contribute to a collective benefit. The difference between public goods and common pool resources is the difference between clean air and a fishery. In the latter case, if I take fish out of the ocean, they're not there for you. In the case of clean air, presumably we can all enjoy it without intruding on others, but they're really two ends of the spectrum, and I'm going to group them together for today. So we've already talked about two sorts of public goods: information, as in the bird flocks, and tumors, but organisms in the ocean form siderophores to lock up, to chelate elements that they may need. Plants have to share water tables and therefore have to withdraw from that water table at rates where there's a collective cost to their withdrawal. I'll come to an example that really could model this system in a few minutes. But even bacteria cooperate, forming the biofilms that keep our dentists in business. One of my favorite films, The Little Shop of Horrors, and one of the great scenes in there involves the dentist who enjoys too much inflicting pain. I actually have a dental appointment this afternoon, so I'm not looking forward to that. But the biofilms are what keeps the dentists in business. But this involves cooperation between bacteria. How do they do this? They produce extracellular polymers, technically called slime, which lead to the production of biofilms. These are the extracellular polymers. And I'm going to show you some work led by my former graduate student, Carrie Nadell, in which we look at why individuals should do this. Some cells don't make the polymer at all, or at least in theory wouldn't have to. Some make the polymer, and I'm also going to keep track of the polymer. And there's a difference, however, as to when they do it. What do the polymers do? They form two functions. One is they are signals of density that allow for what's called quorum sensing. And secondly, they're matrices for growth. So they're essential for the growth of and production of the biofilm. But for example, Pseudomonas aeruginosa produces these extracellular polymers at high cell density, but something like Vibrio cholera does just the reverse and produces at low cell density. So we set out, and this is led by Kerry, but together with Jali Xavier and Kevin Foster, to try to understand the conditions under which this behavior would be selected. Why pay the cost? And the local nature of the interactions between the individual cells, between the individual bacteria is crucial here. So in the simulations, we keep track of the extracellular polymers themselves. You'll see that in this video. And we allow for some to be what we call constitutive slime producers. They produce the polymers under all conditions. And then we look at the Pseudomonas and the Vibrio examples. Some produce it below quorum, some above, and then we allow for growth and see which ones grow fastest. And it depends on the mixing rates and things of that sort, but we can address the question of why these behaviors should be selected and when. I didn't mention nitrogen fixation. That's another example. It actually related to things that Lou did in his thesis, but plants fix nitrogen. That's costly. It can be stolen, the fixed nitrogen, by nearby plants. So under what conditions do you produce this public good? I won't go into that. But a related problem is the production of antibiotics by plants and by bacteria. Costly to produce the antibiotics. There's a collective benefit. When do you do it? Of course, antibiotic use, we're familiar with antibiotic use as a public goods problem in a very different context in human societies because we overuse antibiotics. And there's an interesting trade-off because in a few minutes I'm going to talk about vaccine use. So the question is, why do we overuse antibiotics and there's a tendency to underuse vaccines? And we all are familiar with vaccine hesitancy and vaccine resistance today. So this has been a project that Ramanan Lakshmanarayan and I have been carrying out with the support of the James S. McDonald Foundation. One of the main explanations we think for what's going on is we're asked to use antibiotics when we're already sick and therefore want to get better. We're asked to use vaccines when we're well and therefore there's more of a resistance to it. But we also know, and I'll come back to this later, that this is all embedded in a political context today that complicates the issue. So I'm going to talk about vaccination and mask wearing in a few minutes, but these are also prototypical public goods problems. Vaccination is obviously a public goods problem. We all know about that. I'm just reading two of my three teams that I care about are the Baltimore Ravens and the Washington Wizards, and turns out that the star player for each one of them has elected not to get vaccinated, regarding it as a personal decision, ignoring the fact that there's a public goods problem associated with it. If I don't get vaccinated, then I'm at risk of a higher risk of contracting the disease and therefore spreading it to others. And obviously that problem on a sports team has particular import. Public goods maintenance is essential to the sustainability of our societies. This is from the cover of a book I wrote 20 years ago. The idea of the commons goes back 2 centuries to William Forster Lloyd, who talked about the sharing of grazing grounds. He didn't call it the tragedy of the commons, but that was a term that Garrett Hardin introduced. Lloyd pointed out that individuals would be inclined not to pay the price associated with living in the commons. And Hardin raised this as a problem in the late 50s and said the solution was mutual coercion, mutually agreed upon. That'll be familiar to most people in the audience. For Hardin, what this meant was a very major role for government in imposing that mutual coercion, but it was left to my late colleague, the Nobel laureate Elinor Ostrom, to point out that the government wasn't a necessary part of this, that in small societies like small societies of fishermen, the maintenance of cooperation could arise through shared and mutually agreed upon norms. Therefore, that's turned a lot of interest of a lot of us, like Pete, who's on this call today, to develop an understanding of how norms arise and how they are sustained. But Lynn Ostrom really developed much of the support for this notion of how norms arise in society. And as an example, with two former students / postdocs, Maya Schluter and Alessandro Tavoni, we looked at things like the plants withdrawing from a water table, but also fishermen withdrawing fish from a common pool. And I won't take you through the model that we developed, but in the model, individuals could either withdraw at the collectively optimal rate, or they could withdraw at the individually selfish rate. But those who were withdrawing at the selfish rate would do better unless those withdrawing at the collectively optimal rate would band together and agree to withdraw at the collectively beneficial rate, and to punish those in one way or another who did not. And what we found is on the vertical axis, the degree of selfishness. 1 would mean you're withdrawing at the collectively optimal rate, but 3 would mean you're withdrawing at 3 times that rate. The bottom axis is the frequency of cooperators. And what we found in the model, not surprising, is as long as you could get the frequency of cooperators above a threshold amount, you could sustain a cooperative society, not in which everybody is withdrawing at the social optimum, but in which things are better than if everybody withdraws at the most selfish rate. But it's a bistable system, as you can see. You've got to get the number of cooperators above the threshold amount. And this is reminiscent of the way international compacts are designed, in which they only go into effect if the number of cooperators, the number of those who are signing on to the compact, gets above a certain amount. We examined this further with my former student, Andrew Tillman, and Avinash Dixit, and James Watson, in which former postdoc, in which we allowed for more than just withdrawing at the collective optimum or the selfish rate. Individuals could say, okay, we will agree to withdraw at a somewhat higher rate than what would produce the collective optimum, but well below the individually selfish rate, to try to find what's called the second best solution. What would be best overall, given that we need to have a Nash equilibrium? So happy to send that paper to anybody. Second example with Dixit and Dan Rubenstein is of pastoralism and sharing of grazing ground. I'll go into this in a little more detail. Herdsmen in East Africa share grazing grounds. And then, for example, if Lou's got the next ranch over from mine, we both have, on the average, similar sorts of situations, but maybe this year, the climatic conditions, the weather conditions we're in are not so good. And I say to Lou, can I send my cattle over to graze on your land? And he says, why should I do that? And I say, well, next year the situation may reversed, and then you can send yours over to graze on my ground. So he's got to make a calculation to see if that's worth it to him. So here's the basic framework of our model. We both face good years and bad years. In good years, our yield will be higher. We both invest in our cattle, which are a personal investment, and in our land, which to some extent are a public good. And in a good year, the idea, when Lou's having a good year, maybe some of my cattle, a number M, will be moved from my place, which is a bad year, to where he is, the good year. And as I said, we're both making investments. which we call X and Z in cattle and land. And we first of all compute what the social optimum would be. Choose the transfers M to maximize the total welfare. This is the function that we chose to represent it, but it's not crucial. But let me take you through it. The first term represents Lou's land. X1 are his cattle, and M are the number of my cattle that are moved over. We assume a Cobb-Douglas function, so it's X to the alpha, Z to the beta in terms of the investment. We ask the question, what's the optimal investment? What's the optimal movement? Where the yields are A1 on his land and A2 on mine, and there's a cost function because we invest in cattle and land, and we choose to take this as a quadratic cost functions, but you can also assume that you've got a fixed amount to invest, and you divide it between the cattle and the land. But once we know what the social optimum is, we realize that there is nobody who's going to enforce this social optimum. There's no hardened top-down approach. So we have to ask, is this a Nash equilibrium? And will Lou play this game with me? And that will all depend on his discount rate, how much he values next year relative to this year. But suppose it's not a Nash equilibrium, then we can ask, just as we did with the Tillman paper, are there second best solutions? Can Lou say to me, I can't take all of your cattle, I can't take even M, but I'll take 10 of them. I know that's less than M, and I know that means next year I can only send you M. So this is the way that a lot of these situations are resolved. First of all, compute what the social optimum would be. Secondly, ask, but is that something that's a Nash equilibrium? And it's a game theoretic equilibrium. And if it's not, are there second best solutions? And after we compute the whole thing, Lou says to me, well, you know, you were my advisor and I owe you, so I'll take a little bit more. Well, that's not the way it works in the herder societies, but in those cases, it's a matter of kinship and pro-sociality, caring about neighbors. It may be that my daughter has married Lou's son, if he had one, and therefore that goes into the calculation and makes me, that should go into my fitness function, into his fitness function, and make it more likely he'll play the game with me. So pro-sociality can be important. And that raises the question, why is pro-sociality even there, especially if we're dealing with a non-kin related system? First paper I know on this is by Herb Gintis, where he points out how pro-sociality can arise. Errol Akçe did work on this. Many other people have as well. Avinash Dixit and I wrote a paper a few years ago on how pro-sociality could arise in the systems we were interested in. And basically the way, whoops, sorry about that. The way it worked was that we know that pro-sociality facilitates cooperation. Therefore, we know that if there's pro-sociality caring about my neighbors, this may lead to global cooperation. And I also know that my children will benefit from being in a pro-social world. And therefore, I'm willing to invest in teaching them and their friends about pro-sociality, putting that into the education system, because it will leave my offspring with a better life. So that's the nature of the model that Dixit and I investigated. Individuals invest in education that will improve pro-sociality in future generations. So summary so far, collective action can be effective if it includes enforcement, as in the example of water withdrawal, fish withdrawal. Pro-sociality is an important contributor to the maintenance of public goods and bountiful resources. And in the last part, I want to talk about how collective decisions are made. So I started by talking about animal flocks, groups like the bird flocks that you see on the right, the fish schools that you see on the left, the reindeer herds that you see at the bottom, in all of which individuals are making decisions that lead to these emergent patterns. The first video on here is Ian Cousins' product. Ian was my great postdoc, or maybe I was his, it was hard to tell. We've done a lot of work with Naomi Leonard and our groups on this over the years. But then the next question is, what can we learn from nature? What's different about what we do from, or what goes on in non-human groups, and what we might do to achieve cooperation in our societies? And you're familiar with a lot of these works on this topic. And one of the differences that we pointed out in the paper, which came out just 2 weeks ago in ecosystems, is we have one advantage over non-human groups. I think it's an advantage in that we can build models, we can make predictions, we can anticipate what's going on. And we point out in this paper that we not only should learn from evolution, but we need to go beyond evolution and take advantage of our ability to anticipate what's going to happen and build structures that will protect us there. Two of the urgent challenges are, we're well aware, global health, like dealing with the current pandemic, and climate change. And so I want to turn to particularly first to antibiotics and vaccination, things I've already mentioned, and then to climate change. There is a lot of work going on by economists, especially, on why hesitancy towards COVID vaccines arises. And with Ram Lakshmarayan and Susan Fitzpatrick, we published in Nautilus last year a paper on how we might build trust in COVID-19 vaccines. In a paper that Elon Fisher, Dan Rubenstein, and I have in review now, we point out that there's a difference between dealing with vaccine hesitancy and climate change. In that, if everybody around me gets vaccinated, that provides me protection and reduces my incentive to get vaccinated, maybe. But it's a different situation in climate change. Vaccine hesitancy is an example of the chicken game, in which there's a greater tendency to get vaccinated if others don't, whereas climate change is closer to a prisoner's dilemma, in which inaction is a dominant strategy no matter what others do. Going back to the social norms, and this will be familiar to you, it's interesting that some groups are more likely to be COVID vaccinated than others. There are updated data on this, but if Republicans in this study, which was already last year, were 42% of them were vaccine hesitant, only 12% of Democrats. And you can see this whole spectrum along the way. But we're just coming out with a PNAS special issue on political polarization. And obviously, there's an alignment between vaccine hesitancy and political polarization, which is driving many issues in our society. This will show you this from another point of view. These are data on the tendency of people in different nations to wear masks. You're all familiar, especially if you've traveled in Asia, then in China, in Japan, and Hong Kong. There's always been a tendency during epidemics to wear masks in public. And that continues, obviously. In the Nordic countries, it's just the reverse. There never was, and there isn't today. But in countries like the US and Australia and Western Europe, outside of the Nordic countries, there wasn't that tradition, but now, of course, people, there's been not a uniform, not like in China, but a much greater tendency to wear masks in public. So we've been working, led by my student Mo Zhang-Yang, but with Jürgen Weibel, Kaushik Basu, Alvanush Dixit, all great economists, to try to understand the dynamics of these normative switches. And there are data on it, and we've been looking at this from a modeling framework. Humans, as I said, have the advantage of prediction and calculation. We ought to be able to do better than other species, but will we? Scientific consensus is strong on core environmental issues like climate change, but we haven't taken adequate action to address them. The primary solutions aren't that we don't know what to do, but rather that we don't have the will, or at least governments and peoples in general, to commit to the common good and to cooperate. So to cooperate in finding solutions that benefit everyone. Attitudes towards climate change vary from country to country. This is a somewhat dated study carried out by Resources for the Future, asking questions like, do you believe that temperature has increased globally? Is it humans' faults? Can we do anything about it? And should we do anything about it? And just to highlight one of those questions, in China and in Sweden, two very different political environments, an overwhelming fraction, 95 plus or minus 1% of the people think that it's humans who are at fault and we ought to do something about it. Whereas in the US, that number was 73%. And if we look just at the US, this is a more recent study from Yale University and George Mason University. In 2008, more than 50% of the people were either alarmed or concerned about climate change. That dropped in 2010 to about 39%. By 2016, it was back up to 45%. And today it's back up to about where it was in 2008. What happened in between? We had a financial crisis. People stopped worrying about climate change and start worrying about the short run. We've got to get the economy going together. So that just shows you that external events can dramatically shift attitudes and norms in societies, but those changes can also come within. I already talked about the face mask, and these are events like number of cases in these countries that have driven some changes in behavior. So social norms are crucial. We wrote a paper led by Karina Nieborg some years back, pointing out that social norms are key in addressing these problems. As I said, Pete Richardson, for example, has worked on this problem for a long time. Social norms can change rapidly. Paper on the right that Paul Ehrlich and I wrote. Attitudes towards foot binding, in China, the classic example, smoking in public places, racial equality, gender equality, maybe climate change, and maybe the pandemic can change very rapidly. How do we go about changing them? The central issues are ones of behavior and culture, intergenerational and intragenerational equity, dealing with public goods and common pool resources, and ultimately getting cooperation in the commons, the role of social norms and institutions. We discount the future, and that was crucial, for example, in the Stern report, in addressing, in terms of what the discount rate would be and whether we should and how we should address problems of climate change. We also discount the interests of others. We're not yet in the situation where the person next to us on a plane to China could be talking on their cell phone, but you can imagine how annoying that will be. How do we protect ourselves, others, and future generations against the consequences of our overuse of resources? Can cooperation be extended to the global level? Lynn Ostrom, in some of the last work she did before she passed away, advocated a polycentric approach, meaning small local agreements or agreements between small numbers of countries, which could then be building blocks. And Andrew Tillman and Avinash Dixit and I have formalized this by a model, which I won't take you through, in which individuals are interacting locally. They have pro-sociality towards others in their group, and that may facilitate cooperation and contributions to the public good, and that the benefits of that may leak out ultimately to addressing global problems. This is a manifestation of Lynn Ostrom's idea. We've extended this up, or our group has, to international agreements. Nations have interlocking memberships, and together with George Pacheco, Phil Hanneman, Vitor Vasconcelos, we developed a model in which that takes advantage of the fact that individuals belong to groups, but it's not the simple structure that Lynn Ostrom talked about, because those groups are overlapping. Nations belong, US belongs to NATO, it belongs to the UN, it belongs to the, or I think it belongs again to the World Health Organization. And every decision that the nation takes has to take into account all the groups to which it belongs. And we found that those interlocking agreements, those overlapping agreements, facilitate the potential for cooperation in dealing with global problems. Vitor and I, working with Elke Weber and Sarah Constantino, have been trying to apply this in a modeling approach to understand the acceptance of decarbonization, especially we've been looking at India and China, but ultimately in the US, in which we allow individuals now to belong to groups, but to multiple overlapping groups. Those groups have norms or stances on issues. Individuals have attitudes on their own, and they change their attitudes and opinions based on what their neighbors are doing and the groups to which they belong. On longer timescales, those groups change their attitudes, and we've been trying to relate this to empirical information that Elke and her group will develop on attitudes towards decarbonization. So let me conclude. Public goods and common pool resource problems represent fundamental challenges both in economics and in evolutionary biology. Collective action can emerge from local interactions, some Lynn Ostrom pointed out, the dynamics of these systems play out on multiple scales. Collective decisions can impose the mutual coercion mutually agreed upon that Garrett Hardin talked about. If we're going to manage the commons, we have to be able to link these scales, and what so many people on this call have been working on to address these sorts of problems. In fact, the National Science Foundation has recognized the importance of this in their development of through the Directorate for Geosciences on the dynamics of integrated socio-environmental systems. I think this is where a lot of ecological theory is going in the future. So can cooperation be extended to the global level? Well, we have to overcome the fact that historically the emergence of cooperation within groups has often been to facilitate the and make a beneficial their ability to win in conflict with other groups. If we're going to deal with global environmental problems, we have to recognize, as Pogo did, that the enemy is us. In the global commons, there is no other. We have to all be working collectively. We have to understand that to achieve international cooperation in dealing with the sustainability, we have to recognize that our common enemy is environmental degradation if we're going to produce a sustainable future for our children and for our grandchildren. So thank you very much.
Fantastic. Thank you. Thank you so much, Simon. Can we have a mics off and quick round of applause, maybe? Okay, brilliant. Fantastic, wide-ranging talk there, Simon. So just to re-emphasize what Eric has put in the chat. So if people have questions, can you post them in the Q&A? And we'll work through those. I'll get things going though. So one question, or one thing you were talking about at the end there was social norms as solutions to collective action problems, which is
see if you can see a way of doing it.
Somebody's got their microphone on. Okay. To say so, social norms as solutions. So it seems in the current system or the current world that the social norms are sometimes acting as barriers as well, and that kind of ties into that point you were making towards the end of we've got lots of different groups and potentially different affiliations and different identities. So I was wondering if you could, if you have any thoughts about why sometimes we get these entrenchments and why sometimes social norms are barriers as well as solutions.
Well, I think it's the fact that social norms are problems that allows them to be solutions. And our societies, just as in the bird flocks or fish schools, there often tend to be a small number of leaders and a great many followers. And therefore, I'm using the term social norms here very broadly to include descriptive norms and proscriptive norms. That is, to include just what people tend to do. But in most situations, people aren't making decisions for themselves. They are turning to their neighbors or to their leaders or to their social media or television to guide them on what to do. That reduces the dimensionality of the system, increases the potential for rapid change in the system, tends to get individuals locked into particular positions. But what it means is, to me, think about what happened with the Confederate statues in South Carolina, that some external event can suddenly trigger the switch of a few leaders. Sometimes this works for the good, and we've seen it also work for the bad recently in our political systems, but it does mean that very rapid changes can take place. And I gave you a list of things like smoking in public places or something of that sort. So social norms are often a problem, but you also know that many of the laws and traditions that guide our societies, that you're not supposed to kill other people, you're not supposed to steal, those are begin as social norms that get eventually perhaps formalized into laws and regulations. But the first step is social agreement on what the behavior should be. So I think there's, again, two sides of the same coin, that that social norms can be both problems and solutions.
Thank you very much. I'm going to turn to the question and answers that have been provided, and then we'll come to the panelists in a minute. So Jared Jeffrey asks, nations are sometimes treated as equal individuals, like in votes in the UN General Assembly, but in reality they're considerably different. How do considerable power differences change the way we should model cooperation? And are there analogies in nature or elsewhere for similar kinds of situations?
Yeah, I mean, that's a terrific point. And indeed, the great majority of models that have looked at these ignore this fact. We've looked at this, we have one paper in which we looked at the wealth distribution of countries, but it's absolutely clear that if one doesn't take into account these inequalities in the power distribution, never going to solve the problem, placing special responsibility on countries like the United States to take a lead. And we've seen over the last 20 years how when the US assumes a leadership role, good things happen, and when it doesn't, or even when it withdraws, this makes it much more difficult to address these problems. There are obviously analogies in nature in which there are leaders in animal groups, it initially seems like a separate topic, but in about a month or two, we hope to bring out a special issue of the Proceedings of the National Academy on the dynamics of political polarization, where several of the papers explore the role of what are called elites, which means largely people in government, but also the role of social media and other media in driving this. And I actually think the asymmetries in the system are getting greater because people on television have and our politicians have soapboxes on which they can espouse particular views and change in people's opinions. So the papers in the special issue begin to look at a lot of these asymmetries and heterogeneities. We've been looking at this also, by the way, in a somewhat different context, just in terms of not just of mask wearing and things of that sort, but in terms of susceptibility to COVID, for example, in understanding the spread of diseases. So the assumption of equal players applies not just to these social norm situations, but to a lot of the sorts of problems that are being addressed.
Thank you.
It's a great question.
Yeah, it's a kind of a very interesting area of modeling and research at the moment. Sergey might have a question about it later. Paul Armsworth asks a question about linkages between cooperative situations, and he asks, does the existence of cooperation to address one public good make it easier for cooperation to emerge to address a second separate public good? How much does the answer to that question depend on the spatial scales of the two public goods being similar?
That's a great question, and it's something we've wanted to look at for a while. I don't actually. There probably are papers that look at this. We have not looked at that. It's obviously an important problem. Sometimes it's going to make it easier. Sometimes it's going to make it harder, of course, because the public goods are not, may conflict with one another. I think there are two levels at which this question needs to be addressed, and it hasn't been yet. One is just looking in terms of the political dynamics, because addressing different kinds of public goods becomes associated with different political philosophies, for example, libertarianism. And in that sense, if you can get people together to form a collective, they may be addressing multiple questions at once. There may be side agreements that say, I will support you on this if you will support me on that. But there are other situations in which addressing one public good makes it harder to address a different public good. So I think the premise of the question is terrific. It really is crucial, and I know very little work on this subject to look at multiple public goods at the same time.
Fantastic. I think we're going to turn to our panel, and I think Lou had a question, put his hand up first, maybe.
Thanks a lot, Simon. That was a great talk. This is a question about the potential for changing the individual perception. And as you know, we worked a bit on linking human behavior models to climate models. And one of the key components of that was the time period over which individuals remember, the time period over interaction. And of course, there's tremendous cultural differences of sort of history and how much it impacts individuals. But it's potentially something that could be changed through action. And so, for example, Steve Pacala and his Climate Central program has focused in part on weather reporters who may well be able to remind people of past events. And so are there any models that you know of that actually account at the individual level for these differences in time of memory and perception and associated discounting of the past, and how that ties into sort of social norm development, for example?
Yeah, so it's not just time, but space that's important here. For example, I've got one student who's interested in environmental justice, who's working on how individual, this is Mayank Misra, how individual fishermen, for example, perceive changes in climate change. How does it affect their stock? But going back to your other question, it's not just climate change. A pressing problem, as everybody knows now, is how do we change, what are the best ways to change people's attitudes towards their willingness to get vaccinated? And maybe the best way to do it is, for example, through their local clergymen or their local doctors and things of that sort. so I don't know much work from a modeling point of view on it. It's obviously an important problem, but there's also another way around some of this, maybe, that I think relates to your question, which has to do with various programs to average out the costs and benefits of actions through revenue sharing and things of that sort. So your question's a great question. I don't know any modeling of it, but obviously changing people's perceptions is at the core of dealing with a lot of these problems.
So maybe some of the folks on here can make a dissertation out of that.
Yeah.
Thanks, Levin. I'm going to just go back to the question and answers. So we've had a question that's asking, how difficult is it to change social norms on specific issues when they come into conflict with wider social philosophies? And the examples they put there as decarbonization versus GDP growth, or mask wearing versus individual freedoms.
Yeah, well, I don't have an easy answer for that. In terms of the first example, I've been part of a group over the last 30 years called the Bayer Institute, which has brought together economists and ecologists, and this is the fundamental issue that comes up in dealing with these issues, which is Paul Ehrlich is part of that group and argues most strongly in the group that GDP growth is absolutely the wrong figure to be using. The economists don't necessarily disagree with that, but argue that there are different ways to measure growth, and they're non-destructive ways to improve economic growth. And I think ultimately this just argues for better partnerships between ecologists, economists, and other scientists to figure out how to get this situation that to continue and improve people's quality of life without degrading the environment. And there are a growing number of economists who are interested in and committed to achieving that. Could you go back and repeat the or mask wearing versus individual freedoms? Yeah, I mean that is the core issue that's going on. I don't see that there's a scientific solution to it. There are, first of all, inconsistencies. At least I thought there were inconsistencies, except that I see now that there are, an example of the inconsistency is we've never had much of a pushback against children going into school and getting measles and mumps vaccinations. But now I see that there are legislators in Florida who are beginning to say, well, maybe we shouldn't be mandating those either. We could, the trade-off between individual libertarianism and collective benefits is not, as far as I can see, a scientific question. It's a political philosophy difference. And to some extent, we all value both of those things, but under what conditions does the public interest override individual interest, especially in situations where individuals are not willing to make that calculation themselves? When is it appropriate to have a government mandate on issues? That's at the core of the, I think, of the political polarization that we see in our societies. That's one of the issues at the core, and I don't have the foggiest idea as to how we're going to resolve that. But I absolutely agree that that's become exacerbated as the issue among the G7. It was recently pointed out, or is it the G7 plus one? The US is at the bottom in terms of percent vaccinated now. So this issue seems to be a much greater issue in the US than in any of its other partner countries. And I have to turn to political theorists to try to explain to me what we do about it.
Thank you. I'm going to turn to Nathan now from the panel.
Thanks a lot for the presentation. I learned a huge amount, so it's great. I just had one question. A few times in passing, you said, talked about the human species, and maybe because of the advantage of prediction and calculation, we might be able to do better than other species. So I just wanted to, or worse. So that's the question exactly, is you can imagine cases, so a one-shot prisoner's dilemma, where calculation is going to do worse than if you have a norm where of cooperation. Things like voting and vaccination, if you think of it rationally, that's the puzzle in political science. Why does anyone vote? And then just the one thing which maybe you'll have thoughts on is, for policy, this is a question. Should policy target system one, rational thinking? Should we explain things about climate change in rational terms? Or should we be targeting norms and system two of individuals? So what's the better, it sounds like you've thought about this. So, yeah.
Yeah. Well, first of all, thanks for the question. One of the great puzzles for economists that because they're economists is why the models of rational behavior don't work. Why do individuals? I mean, you're maybe familiar with things like the ultimatum game, in which individuals will make a contribution to a public good at apparent cost to themselves. Presumably because they are supporting some social norm, but possibly also because they're invoking heuristics based on the bounded rationality that Herbert Simon talked about. And so, first of all, I think we've got to step back from our notion that humans are making rational decisions. The paper that Dan Rubenstein, I mentioned in passing, that Elon Fisher and I have in review, is based on work that Elon has largely done in the lab, in which takes into account that when not just reciprocity, but that when individuals are making decisions, they take into account the sorts of predilections they think the individuals they are interacting with will have, their likelihood to cooperate and things of that sort. That's a little different than pro-sociality. So you're in the anticipated response of other individuals, and that's part of it. And that's takes a step in the direction of social norms. So I really do think that we've got to address social norms. We've got to address thought leaders, and whether they are clergymen or doctors or television personalities or athletic figures. It was very distressing to me that the leading players on two of my three teams openly were stated that they weren't getting vaccinated or weren't convinced it's a good thing. There are lots of people who listen to those people. So I think that's where we've got to focus attention. I remember 20-some years ago when 25 years ago, when Bill Clinton was president and Al Gore was vice president, in a town hall meeting, Hillary Clinton was asked, you've got your commitment here and you've got Al Gore, why don't you just go ahead and do these things and push them through Congress? And she said, and she was right, you really can't do that until you've changed public attitudes and opinions towards these issues. So there's a coevolution between legislation and public attitudes on issues. And if you try and push things through when there's opposition, it's going to ultimately backfire, I think. So you've got to find ways to change opinions and attitudes. Not easy.
Fantastic. Another question from the Q&A, which I'm going to summarize as basically, can you explain a bit more about when you talked about endogenous prosociality? How does that work, and how does that not become susceptible to the free rider problem?
Well, I think several of the examples I talked about were examples of the endogenous emergence of prosociality. For example, if I can make the calculation one way or another, if I know that I'd rather be in a pro-social world, but I'm inclined not to be pro-social because I don't think enough of my neighbors are doing it. But I recognize, and this is the work with Dixit, I recognize that if my children, whom I care about, were in a pro-social world, they'd be better off. Then I'm willing to make an investment if I can get some agreement with others in education systems and things of that sort that will encourage pro-sociality down the line. And in most of those situations, well, in some of those situations, there may be thresholds. You've got to get the number above a certain amount. If you can get them above a certain amount, as in the work with Tavonia Schluter, then the cooperative equilibrium is robust to small perturbations. I mean, it could collapse, but free riders won't be able to. You know, you can look at, for example, the Montreal protocols on chlorofluorocarbons as an example of where enforcement, if there's a deviation from it, there'll be punishment. So one or two free riders are not going to undercut the system. If you got a bunch of free riders together who said we're going to cooperate on destroying the system, they could often do it. But I think it's one has to find ways to get us into those happy or sorts of basins of attraction. I mean, you can see that in our political systems, and I think our political system is deeply threatened now because previously individual free riders from the things we care about weren't going to get anywhere and would be but now if you get them all those banding together to undercut crucial aspects of the system, I think democracy is in danger.
Yeah, so I guess it's one of the reasons that humans are different to other species is we have this ability to reach agreements, to communicate, and then for those kind of norms or those systems that prevent free riding to persist over time, right?
And of course, that includes designing systems which will have these built-in, like the Montreal protocols, that will have these built-in protections that will prevent free riding.
Okay, fantastic. I'm going to come to the last two panel members, and I think that will be enough questions for you, Simon. So the end is near. We'll turn to Pete and then Mathis.
Go ahead, Pete.
Pete, you got a question, Pete? You're muted.
You are muted.
Eric, can you
all of your valuable words there are being lost to us.
Eric, can you unmute Pete, maybe? There we go.
There we go. Sorry, my internet connection is not the best. So, Simon, you certainly have pointed to the importance of institutions and prosociality in solving dilemmas of cooperation. What do you think the main evolutionary motors are that make people capable of deploying prosocial emotions and norms to guide our behavior? Where does all that come from? I think of Bill Hamilton's rule as kin selection rule as predicting that cooperation is going to be grossly undersupplied by nature, and humans seem to be able to supply more cooperation than most species. Where does that come from, do you think?
That's a great question, and you've done more on that than anybody I know. But of course,
did that work?
Yeah, Hamilton. Yeah, that worked. Hamilton related kin selection is only one of the mechanisms. We certainly have multiple examples of reciprocal altruism. And we have indirect altruism. You know, the famous quote from Yogi Berra that he may or may not have said, which is if you don't go to other people's funerals, they won't come to yours. So I think it goes back to the cultural evolution in Lynn Ostrom type societies in which individuals develop an indirect reciprocal altruism towards others in the group by sort of collective agreements, and this is what Dixit and Tillman and I have been trying to explore. The hope is that some of that gets extended to individuals more indirectly related, and I don't mean genetically related. I mean in terms of the feedbacks. We tend to care about individuals in our societies more, even if they're not genetically related to us. And I think that is in some ways an extension of Hamilton's rule, but it's related to the local coalitions that have developed. But what's your view on it?
Oh, well, Rob and I have argued that cultural group selection is a prominent motor in developing pro-social norms, and through gene culture coevolution that gets imposed upon our innate social psychology. So people are more prone to affiliate with one another than most other vertebrates, for example.
Yeah, so there's a longer discussion on the whole question of group selection and what it means here. I'm more inclined to be rather leery of group selection in the broader sense that it's often applied. Although, if one thinks there are two mechanisms at least by which evolution takes place. One is the normal thing we think of with natural selection, in which individuals produce babies that have the same or similar traits to what they have, and selection goes on there. There's also the notion of what Dick Lewontin called transformational evolution, and Tim Lenton has been working on, which just is that there's a filtering process that goes on, so that basically the groups that we see today are the ones that have managed to be more robust over time. The example I pointed out in my book is, think about a truck going down a rutty road, and pieces will be falling off, and one of two things is going to happen. Either eventually the pieces stop falling off and the truck is more robust, or else so many pieces fall off the truck can't go anymore. But in any case, the trucks that you still see going are the trucks that have gone through this process, and that's kind of a group selection process, but in which what we see are the results of a kind of evolutionary process. To that extent, I agree with you.
Okay, I think looking at the time, I think we're going to have to make this the last question. So Mattis, I think you are next.
Yeah, so my question would be that many of the examples that you give both in humans and non-humans are when cooperation succeeds, right? And then for the big challenges, the question seems to be, how could we possibly solve these problems if we would? But it seems that in nature, there's also a lot of public goods that are not provided, and there's also a very real chance that we won't solve this, right? And for instance, the pathway through norms, I'm not crazy optimistic, because if we think of us, scientists, and us people on the left of the spectrum, we go to yoga retreats in Bali and conferences all over the world. So, if our norms are already so super far away from what is needed to solve this, I don't really expect, if our norms spread to everyone, that's not going to be enough. So the pathway through norms spreading for sufficiently cooperative behavior to solve this, I'm not super optimistic about it.
Yeah, well, two comments on that. One is it's like Pascal's wager for why one ought to believe in God, but it's also the version I prefer is of the famous physicist who was being visited by someone who, when leaving, sees a horseshoe over the door and says, "Surely, Professor, you don't believe in that, do you?" And he said, "Oh no, of course not. But they tell me it works even if you don't believe in it." So I think we have no choice. You may be right, and maybe then nothing we're going to do is going to work, but we have no choice but to try to do something about it. But secondly, maybe what we learn from this, it goes back to the second best solutions. Maybe those of us who have strong views on one side or the other have to realize that if we're going to solve these problems, we're not going to make everybody, I'm not a vegetarian, but we're not going to make everybody a vegetarian if I were a vegetarian, but maybe we can get some compromise solutions that will force us to relax our extreme views, but also find some compromise that will allow the world to survive. I think that may be the situation we're in the US anyway, in terms of trying to achieve our political goals.
So I totally agree that we should do the best we can and not be super pessimistic. But I imagine for many things, if you make it, so many of our norms are also post hoc rationalizations, right? So if you just make it too expensive to go to Bali on a retreat, then you're going to say, "Oh, I wouldn't do that anyway for the environment." But as long as it's just too cheap, you know.
Well, okay, yeah. I was at, just to close, I was in a meeting many years ago where well, maybe I better not tell this story. Let me yeah, no, I think you're right.
Yeah. On that intriguing note, I think we'll have to leave it there. Apologies if we didn't get to your questions, but I think Simon has given us enough of his time. Thank you very much again, Simon, for an amazing, thought-provoking talk. Just to say that next week's talk will be by Nathan Nunn on cultural mismatch. I'm looking forward to that. So please join us again next week. Does Eric or Sergey want to say anything before we draw this session to a close?
Thanks, Simon, again. Great talk. Appreciate it.
Thank you all very much. Have a great series.
Thank you very much. Yeah, we'll see you next week.
Bye-bye.
Bye.
Bye-bye.